How can I be absorbing heat yet my temperature isn't going up? That's quite scary, and this is what we're going to do. And we get this wrong all the time in the exam. The reason behind is very different to specific heat capacity. Specific heat capacity is the amount of energy required to raise the temperature or lower the temperature by 1 degree Celsius or 1 Kelvin or 1 kilogram of a substance. Yeah, there's a temperature change here. State change is similar, yet it's problematic for students. Yes, young man? It's the breaking the bonds, and that happens at constant temperature. I want to prove that experiment today. Rather than heating, it's easier for me to cool. So we're going to use stearic acid, also known as SALO. So the good thing about this is I don't need to get to like 200 degrees Celsius or minus 0 degrees Celsius to do this experiment. Stearic acid has got a nice temperature of around 50. I think so. We're going to find out today anyway, if it's pure. So boiling water is enough to change that into liquid. The measurements that I'm going to take, every certain time interval, I'm going to measure the temperature. So for that, what do I need? I need a stopwatch. All right, got one here. So I'm going to use my stopwatch. I'm going to start timing, and I'm going to measure temperature and temperature and temperature reading every minute, every second, whatever. Get a result here. What would the graph look like? What would the graph look like? So if I do a graph, what graph am I going to plot, by the way? Yes, it's temperature, again, degrees Celsius, time in seconds. Let's say it starts around 50 degrees. What's going to happen? It's going to cool, it's going to cool, it's going to cool. And then what? I'm interested in that. You are cooling, yet your temperature isn't changing. And that's the beauty. We call this latent heat. So I'm going to prove that to you today. I'm going to find that horizontal line. But guess what? When we do this experiment, it doesn't work very well. Why? How could I improve this experiment right now? Hey, nearly there. Got some more hot water, please. How do I do this experiment? Better. Improving. And this is why. I think this experiment is easy. I only got it out because I want to show you something to improve. There you go. It's this. Right. A data logger. Why is a data logger better than me trying to read the thermometer? No risk of parallax error. Remember that for your test. No risk of parallax error because I'm not reading an instrument. What else? There's no problem with you. It's going to just note the results. But there's an even better answer that data loggers do compared to us. Because what you were saying, what? 1 second, weren't you? What can data loggers do? Any increment. It could measure up to, I don't know, less than a second. Does that make sense? So better. And if we were to connect this to a computer, it would even plot the graph for us. I'm going to have to go on Excel and plot the graph and show you that curve of best fit. So,
every 1 second?
Every 10 seconds probably. Okay, so 1, 2, 3. Initial temperature 66.2. Note. Yep. We're going to do 10 seconds.
65.6.
Yeah, next 65.6. So we're redoing this experiment again, simply because there was too much data to plot. Eventually we found the data logger connected to the screen itself that actually will plot the graph for us. And it's measuring, this one is measuring in intervals of 0.75 seconds. So quite a lot. All right, okay, short intervals. So 3, 2, 1, I am just going to put it here. And I'll just press play, and that should start logging.